All right, so let's work on the second question of the fourth recitation. So we have question 2, where we're asked to calculate the greatest common denominator of A and B. So let's take a look at 2A. For 2A, we have the GCD of 203 and 101. So to calculate the GCD, we have the following algorithm. We have that 203 is equal to 101 times some quotient plus some remainder. So we ask, how many times does 101 go into 203? Well, it can go twice. So we have that 101 times 2 plus some remainder, right, is equal to 203. So this is equal to 202 plus some remainder to reach 203. So in this we see that the remainder is 1. So we have that 203 is equal to 101 times 2 plus 1. All right, so now we repeat the algorithm again by doing a couple of swaps. We're going to move the value of B into the position of A. So there's going to be 101. And we're going to move the remainder, right, into the position of B. So that's going to be 101 is equal to 1 times some quotient plus some remainder. So we ask ourselves, how many times does 1 go into 101? Well, it can go 101 times. Right? So we have that 101 is equal to 1 times 101. So this is 101. How much further do we need to reach 101? Well, 0. Right, so once you reach 0, then what we do is that we look at the previous value of the remainder, right, and that would be our GCD. So we say that the GCD, greatest common denominator of 203 and 101, is 1. All right, so now let's work on 2B. And for 2B, we're asked to calculate the greatest common denominator of 125 and 75. All right, so the algorithm goes as follows. We have 125 is equal to 75 times some quotient plus some remainder. Okay, so we're asking ourselves, how many times does 75 go into 125? Well, if it goes one time, then it would be 75. If it's twice, 75 times 75, that's 150. That goes over 125. So it goes just once. So we say that 125 is equal to 75 times 1 plus some remainder. Right, so how much further do we need to go, right, to go from 75 all the way to 125? Well, we need to go 50 to reach 125. Okay, so now we repeat the process. Okay? So we move 75 to the left-hand side, and we move the remainder to where the 75 was. So this becomes 50 times some quotient plus some remainder. All right, so how many times does 50 go into 75? Well, it just goes once. All right, so we have that 75 is equal to 50 times 1 plus some remainder. So if this is 50, how much further do we need to go, right, to reach 75? Well, we need to go 25 times. Right, so that means that we have that 75 is equal to 50 plus 25. All right, so we repeat the whole process again. We move 50 and we move 25. So we have that 50 is equal to 25 times some quotient plus some remainder. So how many times does 25 go into 50? Well, it goes twice. Right? So we have that 50 is equal to 25 times 2 plus some remainder. So that's 50 already. How much further do we need to go from 50 to 50? Well, 0. So the remainder is 0. So once we reach 0, we look at the previous remainder, right, which is 25, right, which yields the answer that the GCD of 125 and 75, right, is equal to 25. All right, now let's work on 2C. So we're asked to calculate the greatest common denominator of 268 and 52. All right, so the algorithm goes something as follows. We have 268 is equal to 52 times some quotient plus some remainder. So we're asking how many times does 52 go into 268? And it goes about 5 times. So we have that 268 is equal to 52 times 5 times some remainder. 52 times 5 is 260. So how much further do we need to go? Well, we need to go 8 more to reach 268. So we have that 268 is equal to 52 times 5 plus 8. And then we repeat the process. We move 52 on the left-hand side, and we move the 8 on the right-hand side, times some quotient plus some remainder. So we ask how many times does 8 go into 52? It goes 6 times. Right, so we have that 52 is equal to 8 times 6 plus some remainder. So 8 times 6 is 48. So we have 48. So how much further do we need to go to reach 52? So we need to go 4 more times. So we have that 52 is equal to 8 times 6 plus 4. And now we repeat the process. We move 8 to the left-hand side, move the remainder to the right-hand side. So 4 times the quotient plus some remainder. So how many times does 4 go into 8? Well, it goes twice. So we have that 8 is equal to 4 times 2 plus 4 times 2 is already 8. So how much further do we need to go to reach 8? Well, 0 times. Well, once we reach 0, then we look at the previous remainder, which is 4, and that is our GCD. So we have that the greatest common denominator of 268 and 52 is 4.